All right, getting started with Java. So, binary versus machine code. Binary is simply a number system that consists of only zeros and ones. So, binary would look more or less something like 11001101. So, that's just an arbitrary example of what binary looks like. And it's a number based system that is written in base 2, and we'll just get more into number bases in the future. So, that's all you need to know for binary for now. And now machine code. Machine code is a language that is understood by the computer and consists of commands written in binary. So machine code, or we also refer to this as object code, is code that is specific to your computer. So each sort of computer will have a different sort of machine code that it can read. So Apple will have a different machine code, or machine code can only be read by the Windows computer or like the Linux computer. And they are written in commands that are written in binary. All right, so what is a program? So a program is a set of commands that are written in a programming language, which is a structured language that a programmer uses, the person who writes the code like you and me, to communicate with the computer through commands that exist within the programming language. So that's a very superficial and basic definition of what a program is. And three main takeaways is program, which is a set of commands, and a programming language, a structured language, and a programmer, person who writes the code. All right, moving on to languages and translations. So, we have low-level languages. And low-level languages take fewer translations to reach machine code, so that binary code form takes very few translations to reach that machine code form. So while this is very fast, it's actually really difficult to program in. And now high-level languages take many translations to reach machine code, so that binary code form takes many conversions to reach the machine code form. So while this is a bit slower, it's definitely easier to program in. And there are many high-level languages. There's Python, C++, etc. But one main important one that we're learning especially is Java. So in Java, other than the fact that it's object-oriented, it's a high-level language, and is platform-independent, Java has a cool program built into it called a garbage collector that exists within the JVM, which I'll get into a second. And in that JVM, there's an execution engine, and inside the execution engine, there is a garbage collector. A garbage collector. Now, what is a garbage collector? So a garbage collector is a program that monitors created data and automatically deletes it when it's no longer being used or utilized. So essentially what a garbage collector does, it prevents something called memory leaks. And memory leaks is a huge problem because it creates data constantly, but it never deletes it, which is a problem because soon we're going to run out of storage, and we don't want that to happen, right? So main takeaway from what a garbage collector does is that it prevents memory leaks. All right, prevents memory leaks. So now programming tools. What are the different programming tools? Well, the first one is a compiler, a program that converts code in one language to another. And then we have a debugger, a program that allows the programmer to monitor and manipulate data while the program is running. And then we have an editor, a program that is used for writing and editing code. And then we have an integrated development environment, or also known as an IDE, which is a single program that consists of all of the three, which is a compiler, editor, and debugger. And there are many sorts of IDEs, and the two that I personally like to use, is Eclipse, IntelliJ. Those are the two that I like to use. However, there are many more. There's JCreator, there's BlueJ, and there's Dr. Java, and the list goes on. So there are a lot more that you can choose from. All right, Java-specific programming tools. So in this section, we're gonna go briefly into the architecture, the internal architecture of Java, not in too much depth. So just the internal architecture of Java. So let's look at the first one. We're going to start from smallest to largest. There are three main things that Java uses as programming tools. There's a JDK, a JRE, and JVM. And we're going to go over that real quick. So we have a JVM right over here. This is our JVM. A Java virtual machine. And now a Java virtual machine is a program that is inside of the JRE, which I'll get to in a second. And it translates bytecode into code that can run on the local machine. So it converts that bytecode into something that can be read by the Apple computer or the Windows computer or the Linux computer. And it's in the JVM, in the execution engine, where we actually see the garbage collector. And then above this, we have something called the JRE, the Java Runtime Environment. The JRE. And now the JRE consists of a JVM, but it also consists of library sets. And a JRE is a program that allows to run Java applications. And then we also have, overarching all of these, we have something called the JDK, the Java Development Kit. The JDK, which overarches both the JRE and JVM. And then while it also contains the JRE, it also has development tools. And your development tools are none other than the compiler, debugger, and editor. So a JDK is a program that consists of the tools necessary to build and run a Java program and contains both the JRE and JVM. So that's just the basic tools that Java needs in order to run its programs. And all three of these are actually platform dependent. They're dependent on which computer you're using. So while Java is independent, the Java programming tools are platform dependent. And I'll explain why in a minute. So now let's look at how the program actually comes together. So first thing, in this first box, we're going to have our source code. So that's our source code. And then our source code gets sent to the compiler. It gets sent to the compiler. So this box is going to represent our compiler. And compiling or building is none other than the process of converting code from one language to another. And then from the compiler, it's going to form another file that is pretty much written in your bytecode. And then now from here, it can go any direction. It can go here, or it can go here, or it can go here. So now, all of these contain a JVM. This little pink box is going to represent our JVM. Again, JVM is a platform-dependent feature, so it's going to be specific to its computer. That's why I'm drawing out 3 of them. And then, connected to that JVM, we have our computer. So we can have a Windows computer, or we can have a Apple computer, or we can have a Linux computer. All right, those are our 3. Okay, so now let me put together a small animation to help you understand what this is. So a source code is always saved in a .java file, or a .java extension. And this is written in source code, and this is basically interpreted in binary. Okay? So now this is now sent to the compiler. So we go, doo, and now we're in the compiler. So now in the compiler, it changes this to bytecode. And now when it converts it to bytecode, we no longer save this in a Java file. We actually store this in a .class extension. And now it's actually not in a binary form, it's in a bytecode form. So we're gonna erase that. We change that to bytecode. And our finished result is now over here. That's our finished result. Okay? So now from here, we're like, what computer are we using? Well, let's say I have a Windows machine. So I'm gonna go up to this JVM over here. So now this JVM is gonna be like, it's gonna interpret my class file, and then it'll say, it's gonna go line by line, and it's gonna read it, and it's gonna convert all of this to a machine code. A machine code form. And then it'll take this machine code, and I'll go, whoops, got something else on the way. It'll take this machine code, and I'll go to the Windows machine, and it will display whatever the result is. So that is simply a basic understanding of the architecture of, or the internal architecture of the Java programming language. All right, so types of programs. We have two types of programs. We have console applications, which allows two-way text communication between the computer and the user in a console. And then we have graphical applications, which are really cool. These are programs that contain a graphical user interface and or commonly known as a GUI. A GUI. And now a GUI, or graphical user interface, is an interface that consists of both text and non-textual graphical outputs. So in this, we're going to see how we can create a new window. We can create a whole window, and we can have like pictures inside, or like GIFs or whatever. So that's what a graphical application is. Now we also have special graphical applications called applets. So applets are special types of graphical applications that has its own window built into a web page. And finally, types of programming errors. Now the first most common type of error is a syntax or compiler error, and these are errors that are caught by the compiler before the program is executed. So if I go back up to my architecture diagram, let's say we have something in here. We have the .java file, and we're missing something in it that is going to cause a syntax error. So when we go to the compiler and then we try to convert it, it's going to go line by line and try to convert it into bytecode, and then it's going to see that there's an error, like we're missing a semicolon. So it will send it back to here and display the error, and it'll say, you're missing a semicolon at line 51. And then you go fix your error, and you try to run it again, and it'll work. Alright, so those are what syntax errors are. So a syntax error, let's say I want to create an integer a, which is equal to 5. We're going to learn more of what these are in future videos. But let's say I have an integer a in a is equal to 5, and I try to run this. Well, first of all, there's going to be a huge error because I'm missing a semicolon, and that's essentially what a syntax error is, or a compiler error. Even before it gets converted into bytecode, the compiler catches it, send it back to the source code, and displays the error, and we fix it. And now runtime errors. So these are errors that are caught that cause a running program to crash. And essentially, what happens is that, let's say we have a for loop, and we're adding 10, or we're multiplying 10 to an integer number. Soon we're gonna fill up so many spots in that integer, because integers can only hold 2 to the 31st power minus 1, I believe. And soon it's going to run out of space and it will display a stack overflow error or something like that. And now a logic error are errors that produce an incorrect output. So let's say my program was intended to add 5 plus 5, which is equal to 10. In my code, I accidentally wrote int a is equal to 5, int b is equal to 6, and when I say system.out.println, SOPLN for short, a plus b, it displayed, this is a comment, it displayed 11.